It is important when you're using stochastic gradient descent that you, whether you're using batch or you're just using single training instances, that you randomize the order of the training instances. Let me show you what can go wrong if you don't. Let's say you have a classification problem, happy sad classification, right? So you've got a bunch of training instances with some various happy faces, right? They're all slightly different, but you've got a lot. And then you have also some sad ones. All right, so these are all different, But what you know is that the labels on these are happy and the labels on these are sad. And so what you need to do when you're using, so if you were not using the stochastic, if you were just using all the training instances, you would look at all of these values, and then this would give you a gradient for every one of the parameters in theta. And you'd be this tension between, some of the parameters might be pulled one way because of the sad, another way because of the happy. But overall, you do the right thing. When you're using stochastic, you might choose, let's just use the simplest case where we look at one instance at a time. So k is 1 for our batch size. It's got to be random. We have got to, sometimes do some happies and then sometimes do some sads, so that the parameters will be pulled one way. There might be a particular parameter that's pulled one way for the happy and another way for the sad. Okay. Otherwise, let me just describe what will happen. Let's say you went in order and you just fed in every happy one at a time. So read in a happy, adjust theta, read in a happy, adjust theta, read in a happy, adjust theta, read in a happy, adjust theta. Okay, what's going to happen? What's going to happen is every one of your y's, so let's say here, y equals 0, and here, y equals 1. Okay? So you are going to get a situation where you get an instance, y is 0, whatever y hat is. The optimizer is going to say, let's go ahead and adjust all the thetas so that it pushes whatever this calculation is, right? Let's say, I don't know what this function is. I don't really care. I'm going to say whatever this function is going to adjust the thetas such that it tries to generate a y hat closer to 0. And then we feed another one. Adjust the thetas so we get a y hat closer to 0. Adjust the thetas so we get a y hat closer to 0. You know the simplest thing for whatever this function is to do? Just try and learn to always omit a 0. That's what it's learning. Here it's saying, hey, try and do more 0, more 0, more 0, more 0, more 0, more 0. And what it could eventually learn is, I am probably better off just omitting a 0. So that's all that these thetas have been tuned for. Just all tuned to spit out a 0. All of a sudden now, we go in and we say, okay, wait, there's a sad face, and we want to tune to be a 1. And a 1, and a 1, and a 1, and a 1. It's very easy for these thetas to just learn, well, forget what we did before. Let's just output 1s, especially if this is very large, right? We could easily have, 100,000 of these and 100,000 of these. We would want them balanced. You can imagine it wouldn't be very good if we had 100,000 happy faces and one sad face. It's very easy for whatever our function is, just say happy, because you're only going to be wrong 1 out of 100,001 times. That's why we normally want to balance our inputs, so we have as many of different kinds as there are. So this actually happened to me with a student that I was advising. So she was going ahead and had some similar classification. The values were completely different. It wasn't happy and sads, but it was this binary classification problem. And what she'd find is she would train, and at the end of it, when she went to generalize, she would get just 50% accuracy. So it's as good as a coin flip. And the reason is, what was happening is that the training didn't happen, we didn't realize it, but it wasn't being randomized. So the neural net was first learning in the first half of the epoch to output a 0, and in the second half of the epoch to output a 1. And then we go to the next epoch and the same thing would happen. And we get to the very end, however many epochs we ran, then it would just be learning to output a 1, which generalized pretty poorly. You had an accuracy of 50%. You were, half the time you were right, half the time you were wrong. So, got to make sure these get randomized.